interact with them. We have very limited time, I am very much aware of it. So I would request everybody to introduce themselves and say a little bit about what they are doing and for the President to respond. Start with Professor Srinathan.
I belong to the School of Humanities, University of Science, Scientific and Philosophical Studies of Consciousness, and Indian philosophical traditions, history and philosophy of biology, biolinguistics, and scientific studies in culture, heritage, and very recently we have started a program, PhD training program here. We have about 12 students, and you find all the PhD scholars and
Students are on that side.
Why don't you just stand up and raise your hand so that the
Thank you. I'm Dilip Ahuja. I'm with the School of Social Sciences. The quality of elementary education in Chamarajnagar. There we work with government schools, and it is premised on addressing children's needs, relationship with the community, and incorporates local knowledge, traditional knowledge in the curriculum. We also have a project on studying social Karnataka. And finally, this is my interest, is how to make energy systems more sustainable. We have emerging programs, one on water, one on science and society, and the other on sustainability science. Thank you.
Your Excellency, I am Prabhakar Vaidya. You might remember me also. Perhaps I met you about cryptography many years ago. So I am with the School of Natural Sciences and Engineering. I thought I'll tell you the key achievement fungal strains capable of degrading toxic pesticides. With my students, I've been involved in breaking the super key code. Professor Ramchandra, who I think is the best carrier of the Ramanujam tradition in the world, really, engineering. My research interests are in the areas of agroecology and environmental toxicology, biological health and typical thing. Thank you.
I'm Sundar Sarukar from the School of Humanities.
I'm M.G. Narasimhan. I belong to School of Humanities. I also work in history and philosophy of science, but my focus is on biology and life sciences. I've done some conceptual studies in those areas. Thank you.
I'm Padma Sarangapadi. My area of interest is elementary education, and I am particularly interested in
Indian philosophy and consciousness studies.
Your Excellency, I am Arvind Kumar, and we have a program here on international strategic and security studies. And right now we have been conducting academic research on two of our neighboring countries, China and Pakistan. And this program is being guided by one of our colleagues, Professor A. Chandrasekhar, who has not been able to come because of his unwell today. Thank you.
in art such as the Chola bronzes. Last year, Professor Raghunathan and myself published a book on India's legendary wood steel, which I believe funded by Tata Steel, which I believe was sent to you.
Your Excellency, I am Anita B.K. My areas of interest is in the area of elementary education. I also work in the area of gender science and technology.
Your Excellency, I am Shanta Mohan. I am from the School of Social Science. My interest is in the area of gender, women's rights, and work on violence against women. Gender.
I am Raj Kumar. My professional career was at the Department of Atomic Energy. My present interests are nuclear and energy issues.
Your Excellency, I am Raghunathan, Professor of Metallurgy and Engineering of Science, and visiting professor here. And at NIAS, I am interested in materials heritage and also the impact of nanotechnology on society, including possible health hazards.
I am Meenakshi Sundaram. I work in the areas of rural development and decentralized governance. I am also addressing the Department of Space in the Village Resource Center project, through which we create a large number of knowledge centers in rural parts of India.
As part of the NIAS faculty, I hold the chair of Dr. S. Radhakrishnan. I've been working for the last 30-40 years. It's been history, art, archaeology, philosophy, and also literature.
Friends, I have, it's nice to see NIAS you are doing this value system also society should cherish. But I am going to tell you something which I believe is you should look at that problem, because I can't get to anybody other than such a fantastic, experienced people. And even if a river passes through within the country, it has its own conflict. Imagine, Nile River goes through 9 countries, and many rivers go through countries, and so we believe the water management is going to be one of the very important area. How do we handle today? Out of 6 billion people, only 1.5 to 2 billion people get drinking water. And there is fortunately, India has got a tremendous potential of water. It comes in the form of a flood or the form of a drought. These Ganges, then the North Bihar, like that, it's all a drought. So this situation is there. And so we have to address with our constitutional situations the water management. How are you going to do properly water management, particularly the river common to many states in the country, river common to many countries. We have many countries, river also come to us. The psychology and the economy and well-being of the nation. That's one area it looks to be near us, we have to address. That is what I can tell you. Second area which very recently I am pushing that idea, that is energy independence. Energy independence means, all the fossil material, one day it will vanish. It's not renewable, as you all know. Fossil means renewable? It's not renewable. So in such a situation, so oil, coal, gas and all those things have got a finite period. Some the World Energy Forum says for some countries 50 years, some countries 75 years. The gas and the oil, we spend about 140,000 crores per year in importing oil for our transportation sector. Nanotechnology has come in a big way. CNT, carbon nanotube, and silicon wafers, when they melt together integrated circuitry, then connected issues. Then the second area, of course, is nuclear power. Nowadays, suddenly, what I can say, the new thoughts breaking throughout the world, there's a clean energy. It is another source, like solar power is another source. Another thing is about 170 million hectares we have for cultivation today. But by 2020 it will become 100. Then water scarcity comes in. We have to 200 million tons of food that we generate, but we require 400 million tons by 2020. There was less water and less land. You want double the food. So challenges are there. Another challenge. So the cultivation, the extraction of oil, the acidification of oil, this is going to be another area for our independent, our energy independence. That is biofuel, solar power, and the nuclear power. That is going to be our ultimately India has to work. So I want you to discuss about it. What the both areas, water, will it become our conflict generator within the country and foreign countries? Conflict generator, how do you resolve water, international waters? Less water, less people working. Even though we say 70%, people are running away from agriculture, where food production in Haryana and Punjab. So with of course, only less than 5% developed world they spend in agriculture. But we are heading for such type of, not 5%, 50%. Remaining people will take over some other places. So these are the few points I have, and if you have got any doubts, you can come to my website, www.presidentofindia.nic.in. and put your suggestions or questions. I am willing to discuss with you. That's all I have.
Ladies and gentlemen, we at the National Institute of Advanced Studies are immensely pleased to welcome the dignitaries Dr. A.P. Karnataka, Shri K. Rahman Khan, Honorable Deputy Chairman, Rajya Sabha, and Shri M.V. Rajshekharan, faculty and all of you assembled here on this memorable visit of Dr. A.P.J. Abdul Kalam, His Excellency the President of India. I now request all of you to come. I now request Dr. Kasturi Rangan, Director, National Institute of Advanced Studies.
Your Excellency, Dr. APJ Abdul Kalam, Your Excellency, Sri T.N. Chaturvedi, the Honorable Governor of Karnataka, Honorable Sri Dharam Singh Ji, Honorable Sri Rahman Khan, Honorable Sri M.B. Rajshekharan, Honorable Srimati Prema Kariyappa, distinguished guests. It is with a deep sense of pride that I welcome Your Excellency, Dr. APJ Kalam, the President of India, to the National Institute of Advanced Studies. Born out of the vision of Bharat Ratna's late Sri J.R.D. Tata, this pioneering institution of higher learning was launched by the founder himself at Pune on January 16, 1989. The institute, in his vision, would bring together exceptionally gifted men and women from different streams of national life, from both the government and non-government sectors, for a better understanding of each other's interrelated tasks and problems, and for assisting them in developing the best means to deal with their respective roles. The NIAS, under the distinguished leadership of its founder director, Dr. Raja Ramanna, and subsequently under the equally distinguished Professor Rodam Narasimha, has scaled great heights in terms of excellence and creativity in research, particularly on multidisciplinary areas. The organization of several courses and seminars undertaking projects of social relevance such as gender studies and education, as well as carrying out multidisciplinary research encompassing the disciplines of natural sciences, social sciences, and humanity, have made this institute a truly unique institution of its kind. As part of paying our own humble tribute to J.R.D. Tata, the institute management decided to hold lectures in his memory on the eve of his birth centenary year. Today, we have none other than our most respected President Dr. Kalam to deliver this memorial lecture. The theme chosen by President, the aerospace technology, past, present, and future, reflects not only an area which was always close to the heart of J.R.D. Tata, but also keeping in tune with the vision of President of a developed India in the next 2 decades. Needless to emphasize, the President truly symbolizes the spirit of resurgent India that has started playing its rightful role with increasing effectiveness among the Committee of Nations. With his tireless and relentless pursuit of this goal, he has been exhorting the nation at its different strata to rise up to the challenges that India offers. He is at the same time a great source of inspiration to the younger generation, a fountainhead of ideas to intellectuals and academic community, constantly infusing a new sense of confidence to the weak and underprivileged, and an uncompromising champion of sustainable development. The President himself has set an example by his own Spartan way of life and setting an incredible pace of life, bringing the last ounce of his energy. You have thus given, sir, a new meaning to the first citizen of the country. We welcome you to this institute about which you have always shown a special interest. We also have today His Excellency the Governor of Karnataka, Sri T.N. Chadurvedi ji, who always brings to bear his extraordinary level of erudition and scholarship to any role he plays. Sri Rajashekharan ji, true Gandhian, both in letter and spirit, is a person of extraordinary qualities, simple, efficient, ever anxious to update his knowledge and information on issues of planning and development, and above all, an intensely warm human being. We are indeed grateful to you, sir, for consenting to be with us and welcome you to NIAS. We are also happy to have one of my dynamic Rajya Sabha colleagues, Srimati Prema Kariyappa. A person of a high level of commitment and conviction, she is always alert on issues of development, women's role in society, matters crucial to the state of Karnataka. With great effectiveness and skill, she articulates the related aspects during the debates in Rajya Sabha. We are happy to have you, Srimati Kariyappa, for this function and hope you will continue to visit NIAS. Finally, it is my proud privilege to welcome each and every one of you. I see Sri Madhavan Nair, Chairman of ISRO, Dr. Goyal, Secretary Ocean Development, Honorable M.R. Sitaram, MLA, R. Ramachandran, Jarsis Desai, Professor U.R. Rao, Satish Chandran, Srimati Malati Ramanna, and others. And among the distinguished invitees in this audience, it is also my great pleasure to welcome our esteemed associates and my valuable colleagues to NIAS. Welcome also to the members of the media. Once again, I welcome all of you to this important function. Thank you.
Thank you, Dr. Kasturi Rangan. I now have the pleasure of inviting Shri Dharam Singh, Honorable Chief Minister of Karnataka, to address us on this occasion.
ಸರ್ವರಿಗೆ ನಮಸ್ಕಾರಗಳು. Respected Rashtrapati ji, Your Excellency the Governor of Karnataka, Sri T.N. Chadurvedi ji, Dr. K. Kasturi Rangan ji, Professor Balram ji, Madhav Nair ji, Satish Chandra ji, our Deputy Chairman in Rajya Sabha, Sri Rahman Khan ji, our Central Minister, Sri Amir Rajashekharan ji, and Srimati Prema Kariyappa, Rajya Sabha member, M.R. Sitaram, MLA from that constituency, and also ladies and gentlemen, friends from media. This is an important event in the history of National Institute of Advanced Studies. NIAS began a series of lectures years ago to commemorate the birth century of founder Sri J.R.D. Tata. The topics that were chosen for the series were of great concern to Sri Tata. These include science and higher education, steel making, aerospace, technology, population and freedom, etc. Today we are fortunate in having His Excellency, the President of India, Dr. APJ Abdul Kalam ji, to offer his valued views on the past, present and future aerospace technologies as an expert, aeronautical engineer and an eminent scientist. The foundation he has provided for the design and the development of several aerospace projects has made him the most honored and respected scientist in the country. Since inception, NIH is known for its professionalism and serious studies. The government of Karnataka has supported this institute since its inception and continues to both support as well as actively associate with its activities. Sri Tata contributes to aviation are well known. His role in the setting up of the Tata Institute of Fundamental Research and this institute and his constant support for the Indian Institute of Science is very well known, especially among the scientific community. Sri Tata always espoused the cause of aeronautical science and industry in the country. He was also concerned about the aeroplane being used as an instrument of destruction in wars and always stressed the need for using it as an instrument of peace and development. It is very apt that a topic which was very close to the heart has been chosen for deliberation, and I am sure this could go a long way in creating awareness about the past, present and future of aerospace technologies. I thank the organizer for their invitation and providing me an opportunity to share dice with His Excellency, listen to thought-provoking and meaningful talk. Jai Hind, Jai Kalam.
Thank you, Shri Dharam Singh, Honorable Chief Minister of Karnataka. I now have the pleasure of requesting Shri T.N. Chaturvedi, His Excellency, the Governor of Karnataka, to make the presidential remarks.
Respected Rashtrapati Ji, Honorable Chief Minister Shri Dharam Singh, Honorable Deputy Chairman of the Rajya Sabha Shri Rahman Khan, Honorable Minister of State for Planning Shri Rajshekharan, Honorable Dr. K. Kasturirangan, Director of NIAS, Dr. Prema Kadiyappa, the Member of Rajya Sabha, Professor Dilip Ahuja, dignitaries in front, eminent scholars, educationists, scientists, and friends. I deem it a privilege to be present on the occasion of the J.R.D. Tata Memorial Lecture to be delivered by our respected President. The National Institute of Advanced Studies, in order to commemorate the birth centenary of its founder, Sri R.G. Tata, identified 7 issues of deep concern to him for exploration and discussion by renowned authorities. Today's lecture is the 5th in the series. We could not have a better speaker, as was mentioned by Dr. Kasturirangan, than our own respected President to speak to us on the past, present and future of aerospace technologies. You, sir, led the first satellite launch vehicle program and the Agni missile project. You, sir, are one of India's most honored scientists and have provided the foundation for the design and development of several high technology aerospace projects and gave inspiration to others. It will only be appropriate for me to say a word about NIAS, which, nurtured by its founder director, the late Raja Ramanna, his successor, Professor R. Narasimha, and now by Dr. Kasturi Rangan, has carved really a remarkably unique place in the domain of knowledge throughout the world. Knowledge which is seamless and borderless. Knowledge which is universal, encompassing, is focused on the good of man and society. I would like to express my thankfulness and appreciation for the distinction that NIS brought to the country, to Karnataka, in its quest for excellence. The abiding interest and contribution of Sri J.R.D. Tata to civil aviation is well known to this learned audience. We have available to us his beautiful biography by Sri R.M. Lala and selections from his minutes, conversations, speeches and writings which describe his fascination for the world of flying. The first Indian to qualify for a pilot's license in 1929 in England, he came second in an air race for the first Indian to fly solo between India and England. 2 years later, he piloted the inaugural flight between Karachi and Bombay of Tata Airlines. In 1946, Tata Airlines became Air India. In 1948, Air India became the first joint undertaking between Government of India and the private sector. In 1953, when Air India was nationalized, Sri J.R.D. Tata became its first chairman and nursed it for the next 25 years with profound concern and care. Parting with Air India was a personal wrench to him. 50 years after the Karachi and Bombay flight, he rendered his daredevil flight in an identical aircraft of 30s vintage which kept the country spellbound. To the end of his life, J.R.D. Tata was concerned about the state of aeronautical science in the country. A few weeks before he passed away in Geneva, he expressed his concern and his anguish in a letter dated 6 October 1993 to Professor A.V. Krishnamurthy, Chairman Aerospace Engineering, Indian Institute of Science. And I quote, "I must confess to you that I am poorly impressed by the fact that after all these years, India's aeronautical science and industry should have such a dismal record of designing anything worthwhile in the form of any kind of aircraft, including the simplest type of training aircraft, in total contrast to achievements of many countries in the world, including Brazil and China. With due respect to our aeronautical scientists or manufacturers, I cannot see any valid reason for our still being so far behind," unquote. This was certainly written before the success of the Tejas, our indigenously designed light combat aircraft. But his emotionally charged words are expressive of his hopes and his anxieties. J.R.D., however, was a man of unfailing optimism. Even a casual glance at his life and career speaks of the unique qualities of the man: his vision, his industry, his perseverance, his amiability, his inspirational persona, his moral courage and fearlessness, his intellectual integrity. Quest for perfection, ethical approach to life, his unbending fight against all odds, and above all, his faith in the people and the future of his country. All of us are privileged on the occasion of the 5th J.R.D. Memorial Lecture by our honored President to pay our homage to this great son of India, a practical visionary and the rarest of the rare, a true human being. Namaskar, Jai Bharat, Jai Karnataka.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Honorable Chaturvedi ji, Honorable Dharm Singh ji, Honorable Rahman Khan, Sri M.E. Rajashekaran, Minister of State, my friend Dr. Kastur Rangan, Professor Dilip Ahuja, and all the distinguished members of Aerospace community and NIAS. I am very happy to meet all of you. I am indeed delighted to deliver the G.R.D. Tata Memorial Lecture in this beautiful environment. It gives me immense pleasure to be amongst the members of the National Institute of Advanced Studies, scientists, engineers, technologists, and academicians. My greetings to all of you. I was thinking what thoughts I can share with you when we are remembering a great visionary, G.R.D. Tata, who has contributed for the growth of aeronautics in this country. I have selected a topic, your reported past, present, future, but yesterday night the topic has changed in my computer. So, vision for aeronautics. Because so many things happen in India, in the space field, missile field. I felt I want to exclusively discuss aeronautics so that can we have a 150-seater jet. That's the purpose of the focus of my. Can we build? Can we design? Can we build and produce a market? So the focus is in continuation of what the great visionary G.R.D. Tata visualized. Friends, human flight is nothing but a creativity of human mind. It came after several struggles to achieve excellence. In 1892, this I have to tell you, this 1892 story, because the aeronautics community, they have some problem. I am also aeronautics fellow. The problem is, can we do it? Can we do it? Particularly the aeronautics committee has got this syndrome. Now, it is a syndrome means it's the science, technology, management, bureaucracy, politics, all combination in connect with the aeronautics. Now, this the Kelvin name is very popular name. All of you would have known that he was the president of the Royal Aeronautical Society that period 1907. Lord Kelvin said in 1892, heavier than air flying machine are impossible. This is what he said. A big scientist said that, 1892, because he derived that idea because the human always, always he want to fly with attached wings, and many failures were there. So he based on these thoughts that it's very difficult. Heavier than air flying machines are impossible, he said. But 1903, Wright brothers made it possible to fly in December 17, 1903. Nothing is impossible in science. So that's a message I would like to give. Now, the G.R.D. Tata was the first visionary leader who started aviation on October 15, 1932. October 15, 1930, that means I was a one-year guy at that time. The first flight of India civil aviation took place from Karachi to Ahmedabad and on to Bombay. His efforts led to the birth of Air India in 1946. And let us recall his word. This in his biography, I read it. Let us recall his word. With Air India, I was creating something new. something entirely new. And therefore, I was creating history in a small way, so I did not have to have the responsibility for the past. This is what he said. We can see how a creative mind blossomed the aviation in India, how that vision of aeronautics can take a real shape now. The need today is for the design, development, production and marketing of a India-made 150-seater passenger jet. I am marketing this today, that 150-seater passenger jet. LCA, light combat aircraft, which I was involved, my friends are involved. LCA has been successfully flight tested and is going to production phase, and the production phase, and is entering the export and the advanced satellite launch vehicles such as PSLV and JS. In the one side, we have LCA is flight tested and is going to production phase. Another side, ALH in production and is entering to the export market. And advanced satellite launch vehicles such as PSLV, GSLV are being made in the country. ISRO is the main focus. They are doing this job. Then strategic missiles with re-entry technology and supersonic cruise missile are operational. With this strength, India definitely has the capability to design, develop, operationalize state-of-art passenger jets in most cost-effective manner. Now, if you look at this is ISRO, Indian Space Research Organization profile. This is Ministry of Defense DRDO profile. This is aeronautics, multiple organizations including HAL, NAL's contribution. You can see this, the type of launch vehicles, what ISRO has done, and it gives a message that self-reliance in space technology and competitive launch services and space technology for societal development. This is the message ISRO people are giving. If you come to the missile area, particularly this where Prithvi Agni has gone into production, and the another is the BrahMos. BrahMos is the operational strategic system. This is the you can see all of them is operational strategic system and critical technology. The supersonic cruise missile, if we export tremendous export potential, is a joint venture between Russia and India, and this is a unique thing at the moment in the world, and it's a two country joint together, best has come for the world. Now, of course, ALH it is one of our very success story, and Nishant and Saras is flight test has commenced, and Lakshya and Nishant unmanned vehicles, and this is for the by target testing, this is for the reconnaissance, and there are many, and also light combat aircraft is flying now. So you can see this profile when you see definitely the people of this country should have a confidence that we can make it. We can make it. Now, let us see the technology you need for a passenger aircraft. A lot of technology you need. For example, digital flywire system is very important. Even the passenger jet aircraft, it emanates from the light combat aircraft. It has done 440 hours flight, and advanced materials like composite area, the wings, what is made in the LCA, that also be useful for the passenger area. Advanced avionics and easy roll change and multi-mode radar, glass cockpit, and general system, carbon brakes, and all of them. Many of the system what we have got for our light combat aircraft has got a direct relevance, particularly software, hardware, to the passenger jet aircraft. If you look at the next one is the is the advanced software modeling and simulation. This work of light combat aircraft led to virtual reality and then interactive graphic for the finite element modeling, and from the design from the computer to the production phase it is possible. And you will find development of a CFD codes for design, analysis and internal external flows for subsonic and transonic speed. All these things possible. The number of software packages, digital markup, and then the Ironbird testing, all these things, a unique test program came out of a light combat aircraft, and definitely this becomes one of the input for the passenger aircraft. Of course, it has its own challenges that I will be coming to you next. Now the control of our light combat aircraft is a big movement, digital flight control, when we are designing in between, and immediately 1998 India became a nuclear weapon state. There was a technology denial. We were working with the USA, and they stopped giving the technological participation. Then we have to form a national team. The national team that clearly indicates that for national best bringing together, and we can do any difficult missions, and we did it actually. The computer control laws and digital flight control through the national, and also wings have been that also a national team was responsible to build that one. National team means you bring the best minds of the country, put them at one place, they work and give the fantastic results. The next one will be of course, this is LCA will be graduating by 2010 through a medium compact aircraft with the twin engine configuration, stealth characteristics, and your tailless design, and the most important, the thrust vectoring nozzle. This is a passenger jet aircraft. It may be one of the very important requirement it will be. The next one is the passenger jet. What is that passenger jet? We have Saras NAL is doing, we have done the LCA, we have our friends are flying, digital fire, advanced avionics they do, composites, lamination, aero. These are the results of our existing programs. So, and then the development strategy should be the technology partnership, and unducted fan, and 150 seater. This is how the configuration will emanate. Next slide. Now we have this BrahMos supersonic cruise missile, and this is a joint venture of Russia, India, and already it has gone 2 services accepted and is going for a production. And this is it gives a lot of technology, long flight range and higher district capability, short flight time, and varieties of flight trajectories, higher effectiveness, and universal missile for multiple platform. And then the next one will be this is the hypersonic reusable missile. What I was talking, supersonic cruise missile. This is another one, graduate dual mode ramjet, scramjet area. There is a lot of work. Some of our laboratories, some of our academic institutions are working in the supersonic combustion area, and sustained hypersonic and air breathing flight. That what it aims at: payload delivery, reconnaissance, recovery system, and the multiple mission of launch and evaluate launch. This is the design stage. The next one, this is our famous thoughts going on for some time, multi-purpose aerospace vehicle. Now I am glad ISRO also thinking now they are the single stage to orbit, the reusable system they are thinking. And this my friend Gopal Swami, and he for a long time he was working with me and Dr. Arnachalam. And the idea is now all these class of vehicle, if you see the Energia, Space Shuttle, Proton, Russian, and then our then Ariane, our GSLV. All these guys, what they do is they put whatever 3 to 4% payload they put in the orbit. That means 100 tons for takeoff, they put 3 to 4%, 4 ton, they will put low Earth orbit. The idea is by using the aircraft like operations, using conventional runways, extensive reusability, more than 100 times, higher payload efficiency, drastically lower launch cost. You see the type of cost it goes down. The idea is to add this air collection. You in the flight itself, you do the air collection and get the oxygen. So you don't need to carry the oxidizer. Only you have to carry the fuel. And all the study indicate the nearly 15% of payload in place of 3 to 4%, it will carry 15%. So this is another area. They originated from India, and many are looking at it very seriously, this idea. Next one. Now this is the type of trajectory. Initially it goes like the rocket takeoff, and then it cruise for some time, and then 100 ton LOX it collects, that is a reactor, and then it adds weight 100 tons, and then it goes like the rocket and puts the about 15 to 16% payload in the orbit. So this is the concept stage and the design stage, and now it has graduated to the design stage. Next. Friends, the hyperplane technology, scramjet technology, in-flight air liquefaction, the hypersonic aerodynamic design frame, then propulsion airplane integration, recovery system, precision guidance. You will find many technologies common, but in the type of material technology, recovery technology, and supersonic combustion, that are the challenges for this type of a system. And of course, Professor Satish Dhawan, my guru and guru for many, and he proposed an idea: bird is airborne by the flap of its wings, by a flap of wings. He has written a book, Aerodynamics of Flight. This data can be processed further to obtain power, energy and needs. Dream of a visionary. He said, why can't we make an aircraft like bird flapping its wings in milliseconds? That is, it takes very short time to take off. This flapping idea, it was an idea for some time back. Now a lot of experiments have started throughout the world, so that the evolution of new generation of aircraft is possible. Next slide. These are morphing airframes, nothing but there's a flapping, at the same time reconfigurable wings will taking place. Next. Friends, aerospace systems integration, then the technology level, you will find these are the technology level. One is GSLV and Agni, and our LCA, various technologies, then additional technology, nanoscience, nanotechnology is coming in. The smart unmanned combat supersonic stealth aircraft with multi-role capability, weapon delivery system, automatic takeoff and landing, human intelligence. These are the missions is going to take place in future. Now with this, I would like to say that the national aero policy, what we need now, strength of the civil and military aviation sector should be integrated to bring in synergy in the aviation sector. Then National Air Safety Advisory Council to interact with the pilots and design, development, training institution to establish high standards of professionalism and flight safety. This is one of the recommendations of my committee. Participation of industries in production of auxiliary airworthy components and system to make India self-reliant in this sector. Then implementation of this national policy, what is needed, I pushed it somewhere 2003, then Air Chief Marshal Krishnaswamy pushed it last year. So I believe this implementation, this national policy will usher in an era of high technology, high skill industry environment, resulting in generation of net assets, wealth and employment in the country. This is, I am going to push it, that is a policy of a national aero policy. I will push it with all your support. Friends, with this I would like to say Beyond 2020, the aerospace world will enter into space industry and space tourism. And now I'll go to the next important thing. This in 70s and 80s, the challenge thrown by the nation's desire to achieve self-sufficiency in aeronautical and aerospace arena has been the reason for the growth of aerospace education and research in the country. Several innovative programs and highly acclaimed departments in many universities, IITs, IICs started blossoming and flourishing. This was also the time period at which the program for satellite launch vehicle development and programs such as LCA, ALH, IGDMP has been the most visible national initiative. At that time, the aerospace had also been a hard engineering subject. Today, aerospace and aeronautics encompass many emerging areas such as software, material science, control and guidance, and computers and communication technologies. This multidisciplinary area can only be developed by uniting many minds working in diverse areas. One such vehicle that would unite the alert mind is a national vision like IGDMP, LCA or ALH. Looking at the current scenario, the mission mode approach to develop 150-seater passenger aircraft would be technologically satisfying enough to attract youngsters to take the aeronautical education, and research would make economic sense and at the same time meet the national requirements. In conclusion, technologies in the field of aeronautics, space and missile are converging. This convergence will lead to a cost-effective, high-quality design, development, production of the various types of aerospace systems such as 150-seater passenger jet, then supersonic unmanned combat aircraft, hypersonic reusable missile hyperplane, planetary missions including manned mission for energy and water. With vast infrastructure and human resource in the aerospace sector, India definitely can launch such a mission with international partnership. Nuclear reactors to produce electric power have come out of Atomic Energy Commission. Launch vehicle and satellites have come out of Space Commission. Strategic missiles have come out of Powered Guided Missile Board. Definitely a National Aeronautics Commission should be planned and should be given the mandate to design, develop and send it to soaring to the Indian sky, a passenger aircraft. Whenever 150-seater aircraft flies in our sky, GRD will smile. May God bless you all. Now, friends, you may have questions, and I am running behind schedule. I like to take 2 questions, and or if you hesitate to ask me questions, you send to my website www.presidentofIndia.nic.in. I will answer your questions. Okay? So the report is coming to you. You can read it, and then you can ask me any question. Quickly, any one of you would ask? Nobody? Okay, thank you.
I now request. Thank you, Your Excellency. Dr. Kasuri Rangan, H.S.T. Dharam Singh, Honorable Chief Minister of Karnataka, Shri K. Rahman Khan, Honorable Deputy Chairman, Rajya Sabha, and
We have been singularly fortunate in our government of our top leadership. The Dr. President takes every assignment he has undertaken our Commander-in-Chief, but also has redefined his position as the Director-in-Chief and the Writer-in-Chief. We are indeed honored, sir, by your presence. We are thankful to His Excellency the Governor for his presidential remarks. We greatly appreciate his orderly presence at many NIAS events over the years. We are also grateful to Shri K. Rahman Khan, the Honorable Deputy Chairman of the Rajya Sabha, for his years of service to Indian democracy and for the honor his current position has brought us. A true erudite Gandhian for gracing the occasion. Thanks to all of you for coming and being here with us this afternoon. May I request the audience to please remain in the auditorium until the President has left the Institute.